Hello. Today I'm going to solve LRU cache. So here, according to the problem, we have to design a data structure where we will store the least recently used element. So we have to create a class called LRU cache, and we will get capacity, like it would be the capacity of that. In the get function, we will get key, and if that key exists in our LRU cache, then we will return the value. Otherwise, we would return -1. In the put function, we will get key and value. If the key already exists in the LRU cache, we would just update the value of that key. Otherwise, if the capacity is full, then we would remove the least recently used cache and add it to the cache. Let's see what code I have written in order to solve this problem. I have created a node which is actually a double linked list. It connects the previous and next, and it has key and value. Okay, and this is the shorthand method of creating the node. Let's go with the LRU cache. I created this detached node and add this to tail extra function. We just need to create get function and put function. When the LRU cache will be initialized, the capacity would be C, the size would be 0, and head tail would be null pointer. Let's get with the get function. I am first checking if the hash map is already have the key. If there is no key of that, we would return -1. I'm using hash map to store the key and the node. The reason to do that is in order to find the key in big O of 1 average time, I require a hash map. If I linearly search in the node linked list, then I would never be able to find the node in big O of 1 time. It would always require k amount of time in order to find the key and the value. Then I am taking the node attached to that key. Then I am detaching the node from everyone else, and I am adding this to tail. So I'm adding this to tail is because the node would be the most recently used node and the head would be the least recently used node. So when the capacity become full, I would just remove the head and move towards the next. Let's go to the put function. The put function is there I am checking the capacity. If the capacity is 0, I don't have to do anything. Yeah. Then I am checking the hash map is already has the key. If there is the key, then I would just taking the node, changing the value, detaching the node and adding this to tail and just return. If the size is full, then I am taking the head and detaching the head by in order to delete the head, I am storing that head in temp. Then hash map erase of that key. The reason I am doing that erase is if in future it is being searched in the count, it would give negative or it would give 0 as it would not never be found in the hash map. Then I am decreasing the size, then I am increasing the size, then creating a new node, then hashmap.key equal to new node and add this to tail. Let's go with the function add this to tail and detach node. Add this to tail is like nodes next would be null pointer. I would never check if anything is attached to the nodes next. Then I would, if there is tail, then I would attach tails next would be node, node next would be tail, and tail equal to node. Else if there is no tail, that means there is no head too. Then I have to check, then I have to add head equal to tail equal to node. Then detaching the node. I would always prefer to dry run this, it would be helpful for you. The nodes previous, like if there is nodes previous, then it is not the head. Then I would check nodes previous next would be nodes next, and if there is no nodes previous, then it will be the head. Then head would be the nodes heads next. Head would be the heads next. If nodes next is there, then it would not be the tail. So nodes next previous would be nodes previous. Else tail would be tails previous. That's it. This is how I solve this problem. If I copy this code and I have already submitted it, but still if I submit it again, I have already submitted the exactly same code. So let's remove this one actually. I guess this would be submitted. Yeah, this gets submitted. I remove the comments. And it works perfectly as fine. It is accepted. So this is it. Let's see you in the next one. Bye bye.